I'm Anil Kumar. Welcome to my series on mixtures, and we are also discussing another strategy which is called allegation rule. Now, that is a very popular strategy, especially in India, but in other parts of the world, it is less known. So, in this particular video, I'll actually explain you both the strategies and show you how advantageous allegation strategy is. We'll take a couple examples for you to practice, and I hope with that you will really start loving this strategy. So the question here is, Peter diluted hydrochloric acid to 25% instead of 60% by volume. How much pure hydrochloric acid should be added to this 160 milliliter of diluted acid to achieve his objective of making 60% concentrated solution? Right. So basically, because Peter diluted to 25%, what we have now is we have 25% solution and 100% pure solution, right? So we have here 25%, right, and 100%. What we need actually is 60%. We need 60% solution. We are also given that the volume of this 25% solution is 160 milliliters. How much pure hydrochloric acid should be added to this 160 milliliter of diluted acid? That means this volume here is 160 milliliter. Correct. So this question is like phrased in a way which is slightly confusing. So we don't know how much should we place this pure one, so we'll say X for that, and total amount will be 100 plus X. Clear? 160 plus X. Correct. So that becomes the total amount. Normally we are just working on the concentration of hydrochloric acid, and 25% means 0.25. Correct. So we get our equation, and that is we can write 0.25 times 160 plus, that is 100%, that means 1, right, times X, right, in percent will be 1. You have to divide by 100 to write equivalent decimal value, right? So we are writing all the answers in decimals. Okay, now this is 0.6, or you can write 60 over 100, then write the decimal, times 160 plus X. Clear? So you get your equation. Now this is equation in one variable. It can easily be solved. Okay, so 25% means 1/4, correct? So 1/4 means half and half, which is 40. Plus X equals to, multiply by 0.6. So 10 and 6 times 6 is 36, and 6 times 1, 6 and 3, 96. Plus 0.6x. Clear? So we'll just bring constants together and the variables together to find the value of x. Clear? So it's not a very difficult question. However, it takes some time, and now we get 0.4x equals to 6, and then we get 56. So x is equal to 56 divided by 4. 0.4, or you can say, okay, let me put 0.4. Otherwise, you could have treat this as 560 divided by 4. Is it okay? So when you have this, 4 times 1 is 4, 16 is 4, 140 milliliters is your answer. So it says, how much should we place? So we got this should be 140 milliliters. So we definitely get a solution. This is indeed the correct method. However, in multiple choice test question, we are restricted with time. And then allegation method really helps, right? So see how to answer this question with allegation. Now I'll show you the method to do using allegation. So in allegation, what we do is we write down what we have. So we have this 25%, 100%, 60%, all are in percent, right? So let me write these numbers as 25 We have 100, correct? What we need is 60%, correct? Now, if I take away 60 from 100, what do I get? I get 40. On the other side, if I do this subtraction, that is from 60, if I take away 25, then I get 35. Clear? Then I get 35. So that is how we kind of get the infrastructure. That basically means that the ratio of these two to be added is 40 to 35. However, we know that this quantity of our mixture, which was 25%, is actually 160, right? We know this is 160, right? So how do you get 160? Well, clearly you get 160 by multiplying this number by 4. Only then you get 160, correct? So that means you have to multiply this also by 4. Same ratio, correct? So when you multiply this by 4, 4 times 5 is 22, 4 times 3 is 12, and 2 becomes 140. Do you see how easily we get our answer without all this calculation? Now this calculation was still simpler than normally what you expect, right? But here is just a plain and simple way of doing it. So try to understand. You are mixing 25 and 100, which is 100%, and getting 60%, right? So the difference between these, always these numbers will be positive. 100 minus 60 is 40, 60 minus 25 is 35. So that is the ratio in which these should be mixed to get 60%, right? But we have 160 milliliters of this, which you get by multiplying it by 4. So you need to multiply the other quantity also by 4 to maintain the same ratio. And therefore, we get that the 100% pure solution of hydrochloric acid should be 140 milliliters. When added, results into 60% concentrated solution, right? So that is how it should be solved. Now let me take one more example. So the question here is, I have two sugar solutions. The concentration of sugar in them is 30% and 15%. What quantity of these should be mixed to obtain 600 milliliter of 21% concentrate solution, right? So this time we have these two solutions. Once again, I'll draw a similar picture. We want the third thing, but we know the mass of the third thing, correct? Okay. Now here we know that this is, one of them is 30%, okay. The other one is 15%. We want something in between, which is 21%. We also know that this quantity of 21% is 600 ml. Correct? We need to find the quantities for the other two to be mixed. Right? Now definitely, you can use the equation. Very simple. 30% of, we don't know what quantity, let it be x, and let this be y, correct? So x plus y is 600. So we get one equation, which is x plus y equals to 600. The second one, of course, is 0.3 times x plus 0.15 y is equal to 0.21 times 600. Now we have two variables and they can be solved. Perfect. And you will get your solution. I'm not solving them, but we'll use allegation, which we just learned, right? This is a good idea. So using allegation is, we know these two quantities, which are 30 and 15%. And what we really want is 21, correct? Okay. Now, let's find the difference. So what is the difference between these two? 21 is bigger, so 21 minus 15 is 6. How about 30? Well, that will give you 9, right? 9. So basically, for every 6 units of 30% solution, we have to add 9 units of 50. Is that clear? So those are the quantities. Now, if you add them, what quantity do you get? That will give you 15, right? That will give you 15. But what do you need? You need 600 milliliters. Well, to get 600 milliliter, you need to multiply this quantity by what? Well, I want 600. Units are milliliter for me. So I have to multiply by 4 will give me 60. That means 40. So that means I should multiply this and this by 40 to get my answers, right? So 6 times 4 is 24, 240. 9 times 4 is 36, 360. When added will give you 600 milliliters of the concentrate solution with 21% concentration. How much time does that take? So within 2 minutes, you understand? If you follow this method, within 2 minutes, you can solve. With practice, less than a minute. You get my idea, right? So allegation is really a very, very effective way. I hope you understand and appreciate it. We had 2 different types of questions here. The third one is we have already shared with you earlier, but however, I will attach it with the same file so that in one spot you get variety to practice. That should really give you a lot of confidence in using this new method, which is allegation method. I hope that helps. In the solution of this question, I'm going to give you a few concepts about a shortcut method of solving problems related to mixtures, which is also known as the allegation method. So what I've done here is taken 2 related questions. As you can see here, these are multiple choice questions. Now these are very popular questions from many test point of view, and sometimes you are required to answer these questions within few minutes. Let us see how to solve them in standard way and also using the shortcut which is normally called allegation method. The question here is, vessels A and B have mixture of milk and water in the ratio of 1:4 and 2:3 respectively. In what ratio should the quantities of mixture be taken from A and B to form a mixture in which milk and water ratio is 2:5? 4 choices are given to you. Now, same question can be asked in a slightly different way, so we'll kind of modify this. Related question here is, vessel A and B have mixture of milk and water in the ratio of 1:4 and 2:3 respectively. Both mixtures are poured in a bigger container C of capacity 70 liters. If water is 150% more than milk in this container, then find the quantity of milk in vessel A, right? So that's the question, which is a test problem for you, in which again we have 4 options. And this test problem should be solved within few minutes, right? Let us see how to first apply the standard method of solving a mixture problem, and then we'll learn a trick, and using the trick we'll solve question number 2. So here is my solution to the standard mixture problem. So we are talking about 2 vessels A and B, right? So let us say these are the vessels A and B. And what we do here is that we take up amounts from them and mix them in vessel C. What we are given here is that the vessel A has a mixture of milk and water. Let's say the mixture is of milk with water, and the ratio is 1:4. As far as B is concerned, the ratio of milk to water is 2:3. And when we combine them in C, then we want ratio of milk and water to be 2:5. So what quantities of each should be mixed? That is the question, right? So then we'll know what ratio will there be for these two. So let us say we mix x of A, right? So let's say x of A and y of B to form C, whose ratio is 2:5, correct? So basically, if you take X amount of A, then how much is water and how much is milk? Well, since we want milk to water ratio, let me write like this. What we want is milk to water, right? And we want this ratio, milk to water, to be equal to 2/5, right? This should be 2/5. Now, as far as milk is concerned, if we take out, let's say, x liters of A and y liters of B, then the milk will be how much? It'll be 1/4 of x, right? The ratio is 1/4. It'll be 1/5, right? Total is 5. Since it is 1:4, total will be 5. So the milk will be, in this case, 1/5, right, of x plus. From here, milk is 2/5, right? So 2/5 of y. As far as the water is concerned, it is 4/5 of x and 3/5 of y. So that becomes the ratio of milk and water. So if we slightly simplify, fortunately we have same denominator of 5, we could just multiply everything by 5 in this case, and what we get here is x plus 2y over 4x plus 3y. So 2/5 is x plus 2y over 4x plus 3y. Let us cross multiply. So we get 2 times 4x plus 3y should be equal to 5 times x plus 2y, right? So opening this bracket, 8x plus 6y should be equal to 5x plus 10y. Bringing the terms together, so let's bring x here. So we have 8x minus 5x equals to 10y minus 6y. So that gives us 3x, right? And this gives us 4y. So the ratio of x to y will be equal to 4/3. Clear? So we get a ratio of 4/3. So we have our answer right there. So that is in what ratio should the quantities of mixture be taken from A and B so that the ratio is 2:5. So our answer here is 4:3. So we get B as the right option. Is that clear to you? So that is the standard method which is normally utilized to solve a mixture problem. Now this was simpler since the denominators were same, right? So the idea here was to explain you the method. Now let us look into the allegation method, which is the shortcut method. So let us see how this shortcut method works. So I will show you on one corner of this page. Let us say, let's work it here, right? So now we'll do allegation method. Now in allegation method, we concentrate, rather focus on one thing. So let's focus on milk itself. So as far as A is concerned, what is the ratio of milk here? Well, if you look into A, the ratio of milk is 1:4, means 1 out of 5, correct? So let's write A and B here. In A, we have milk in the ratio of 1/5. In B, the milk is 2/5, right? And when we do the combination, then what do we need? We need C with 2 out of 7, right? 2 plus 5 is 7. So we get here 2 out of 7. So that is required, C. Correct? So this is what is required. Now, these ratios you could always multiply by a number and get rid of denominators. So in this case, it could be 35. So we get 1. Let's do it. So I will write the second. This is the first step. We just write the ratios as given to us. And in the second step, we write simplified version. So in simplified version, what am I doing here is, let me just mark this out. There's very little space, but I don't want to move to the next page. Well, we have A, B, and C. These two quantities we need to figure out in what ratio, and C. Now, if I multiply everything by 35, then we get rid of denominators, right? So that gives us 7. And if I multiply this by 35, means 7 times 2, 14. And as far as C is concerned, it becomes 10, right? So we get ratio of milk we are comparing, right? We are comparing milk at present. So our focus is quantity of milk in each, right? So the quantity of milk which we're talking about is 7, 14, and 10. Now the allegation is you have to subtract the number. So when you do 14 minus 10, you get 4 here. Do you see that? And on this side, if you do 10 minus 7, always quantities are positive, we get 3. But do you see that? We get a result which is 4:3 in single step. And we get our answer within a minute's time. Do you see that part? I hope you appreciate this. So what we have done is, we've just written this question, finding the ratio of milk in all the 3 containers. Here it is 1 out of 5, there it is 2 out of 5, here it is 2 out of 7. Taking away the denominators by multiplying by a common factor, we are working with numbers, and that is what I call the simplified version of our allegation rule. And the rule is very simple. You just subtract what you need from the other 2 quantities and write the positive values. You get 4 for A, 3 for B. That is the ratio. 4:3. That's the answer. Does it make sense to you? So this is the method which we are going to apply now to a more difficult question and see how those kinds of questions can be solved within few minutes. Now here is the second related question. So with a minor variation. The question here is, vessels A and B have mixture of milk and water in the ratio of 1:4 and 2:3 respectively. Both mixtures are poured in a bigger container C of capacity 70 liters. If water is 150% more than milk in this container, then find the quantity of milk in vessel A, right? So it's a very tricky question, but we are going to use the concepts which we learned in our previous first part of this video, right? So I've taken exactly similar values so that you can correlate, and we'll straight away start with the allegation method, right? So, but before that, we need to understand this statement, which is if water is 150% more than milk in this container, right? So that is giving us the required ratio. So when I say 150% more, that means what? Let's try to understand this. So we have milk and we have water. So if I take milk as 100, water is 150% more, means it is 100 plus 150. Does it make sense to you? 150% more, right? So that means if the milk is 100, then the water is 250, correct? Now this is what ratio? Well, let's simplify this, right? So we can just divide by 10, there you go. And we can divide by 5. So we get the ratio of 2:5. Do you see that? So that is the final ratio in the container C. That is what we need. Perfect. So it is very, very similar to what we just started with. Correct. So again, what we have here is our container A and our container B. What we need is ratio of 2:5. Perfect. So in this container, milk to water is 1:4. In this container, milk to water is 2:3. And what we need, milk to water, is 2:5. Correct? Now, whenever we apply allegation, as explained earlier, you could either work on milk or on water as you wish. I'll keep it milk since it is related to what we did, and it's kind of a repetition so that you understand how exactly this process should be applied. So as far as milk is concerned, so we are focusing on milk. So as far as milk is concerned, here 1/5 is milk, right? So 1 out of 5 is milk. In this case, 2 out of 5 is milk, and here 2 out of 7 is milk. Correct? So that is our basic structure to begin with. Now, let me write down a simplified version. That is, we'll multiply every number by 35, right? So we do everything times 35. The idea is we want to avoid the fractions, since even subtracting fractions could be very complicated, right? Okay, so what we have here is this is our A, this is B, and this is C for us, correct? So again, as far as A, B, and C are concerned, the quantities, when you multiply by 35, okay, not 37, 35, 5 times 7, correct? So what you get here is 7. So this is 7. This one is 7 times 2, 14. Here, 7 goes 5 times. 5 times 2 is 10. And the ratio which we get is what we got last time, same ratio. What do you get? 10 take away from 14 is 4. 10 take away from 7 is -3. But you have to always write positive quantities. Quantities are never negative, right? So again, we got this ratio of 4:3. Now, let us see how this question is different from the previous one. Now it says here, both mixtures are poured in a bigger container of capacity 70 liters. That means total is 70 liters, right? So if I have 4:3, then what is the total? Total is 7, right? But instead, if I have 70, I have to multiply them by 10 each, right? So it becomes 40:30. Is it clear? So 40 of A, 30 of B. Perfect. So we have got at least the quantity of A, that is the X value, required to get the result. Now, the question really is, it's a complicated question, really. A lot of steps involved. It is to find the quantity of milk in vessel A, and in vessel A, quantity of milk is 1/5, right? So milk is 1/5, correct? We need to find the quantity of milk, right? It is 1/5 of the whole. So again, here we'll do 1/5 of 40 to get the result, which is 8 liters. So the option here is option C, 8 liters. Does it make sense to you? Perfect. So a lot of steps involved. Without allegation, this question could take 5 to more than 5 minutes, right? Now here, with allegation method, now you know how to write these things, right? So the ratio of milk is 1:5 in container A, 2:5 in B. What we need is 2:7. Taking care of the denominators, we get 7, 14, and 10. That means the ratio is 4:3. 4:3 means in a total of 7 liters, we have 4 and 3 liters of A and B respectively. But we have 70 liters, that means 10 times. So we have 40 liters of A, and if we have 40 liters of A, then milk is 1/5. 1/5 of 40 is 8 liters, and that is our answer. Perfect. So that is how we are going to solve this question. Once you understand this method, then this type of question can be solved. You can time yourself within 2 minutes, right? And once you get practice within a minute, it should not be difficult, right? So I hope that helps. Once again, thanks for joining me, and keep posting brilliant questions, and we'll come out with amazing solutions to them. Thank you, and all the best.